Hello everyone. Thank you so much for joining the session. We have some people who have already joined the call. Thank you so much for your patience. We will just wait for another 5 minutes so that we can give an opportunity for other people to join as well. So, meanwhile, if you have any questions or anything, you can already send it to us in the chat. Okay, we will start in 5 minutes and then I will introduce my colleagues also. Thank you. Okay, I guess we can start. All right. Thank you so much again for joining the session. Today we are joined by two of my colleagues, Leonard and Geoffrey. They are the main team from ENVI-met. They talk more about the software and how you can work with ENVI-met and how you can work on microclimate simulation. They're going to touch upon what microclimate is, how you can use ENVI-met, and certain case studies will also be discussed, which have been done by the team, which is also specific to the MENA region. So, hi Leonard, hi Geoffrey.
Hi,
Hi, Natasha.
welcome.
Welcome.
Yeah. All right. So we are One Click LCA. I will give you a short introduction into what One Click LCA does, and then I will hand it over to Leonard and Geoffrey. Uh, so One Click LCA, we are an LCA software. So we have three verticals of tools. We have LCAs for building, we have LCAs for infrastructure projects, and we also have EPDs. So you can get a product LCA, get it third party verified, and get a third party verified EPD using our software as well. We work with the various green building standards that is out there. So if you want to do an LCA for LEED, you can work on it. If you want to do an LCA for BREEAM, for for Envision, for past 2080, you can use our softwares. We also have the largest LCA data sets. We have more than 250,000 data sets. We have integrations with all the tools. Like if your data is coming from a Revit file, you can integrate it. Civil 3D, even a simple Excel file if you have. So how you integrate your data into one-click LCA is entirely up to you. So you can just upload an Excel file also into one-click LCA and do the LCA calculation. A software is used world over and by some of the topmost architects and manufacturers and contractors in the world. Leonard, you can go to the next slide, please. Yeah. So one click LCA, we are a global platform. So we have integrations with Autodesk, with Trimble, with Bentley. We are also they're compliant with various regulatory and certification frameworks all across the globe. So you can also use our Carbon Designer software to work on pre-design or on concept stage design as well. So we have a tool for every stage of the design which can be used. We have an LCA tool, we have an LCC tool, we have biodiversity, we have building circularity tools. So you can all use all of these tools to optimize your design. We have a unique global database. I'm sure a lot of people would have already seen we have something called Material Compass right now, which has the largest database for EPDs. And we also have we are using currently some aspects of AI as well, which is very exciting for us. Of course, in terms of microclimate simulation, we have ENVI-met, which we will learn about a lot more in depth today with Geoffrey and Leonard. So now I'm going to give it to Leonard and Geoffrey to continue. Thank you.
All right. Thanks, Natasha. Again, welcome to the audience today. As Natasha said, we are talking today about ENVI-met. And for that, we have the following agenda. First, we will talk about some basic urban climate principles, get everyone on the same page about what microclimate means and what we actually do with ENVI-met. And then we will dive deeper into the tool, give you a little introduction to what it does, and then also we will have a look at some practical insights from case studies. And then I hope there's some time left to have a quick Q&A so you can ask some questions to us if you like. Before we start into talking about ENVI-met, we want to have to make this little poll here. I want to ask you the question if you have ever worked with micro climate simulations before or overall climate simulations before. Would be interesting for us to know. So feel free to answer the poll. That would help us to get a little bit more information about who's sitting here today behind the laptops. All right. Maybe you may have the question or you don't even know what I'm talking about when I'm talking about microclimate. And for that, I've prepared this little slide to explain you the different scales that we look at in metrology. So basically, we have three different scales that we can do research for. It's the macroclimate scale, the mesoscale, and the microclimate scale. Macroclimate defines a larger scale or has a look at larger scale climate patterns. Phenomena like El Nino or La Nina are a good example, or for example, also the Mediterranean climate is considered to be a macroclimate process. When we look at mesoclimates, we look at climates of specific regions, for example, a mountain range, or a valley, a bigger valley. This is considered to be on the mesoclimate scale. And when we talk about microclimate, we look at the very local scale. So, for example, the shade under a tree, the climate under a tree, the climate under a shading element or the climate next to a building. This is where we are looking at when we talk about microclimate. So the direct impact of the climate onto humans is also a very important aspect that we can visualize with a microclimate simulation tool. And now Geoffrey is going to talk through us through a little bit of why that is important, what that has to do with our cities, and we will have a little dive into the urban climate.
All right. Thanks, Leonard. Well, so I think the main phenomena we have to talk about is this urban island effect. This is a major effect in our cities, and this can affect the temperature in cities by 5 to 10 degrees compared to suburbs. So this kind of add up from the extra global warming that we're experiencing at the moment. So 5 to 10 degrees, you have to take into account the extra global warming, which could be up to 3 degrees at the end of the century. And on the right, I just took a satellite picture from ESA, which shows the influence of different type of suburbs about Paris. So if you see in red, the city center of Paris is way warmer than the suburbs. On the left side, you see the Bois de Boulogne, which is a park in Paris, which is greener, and you see it's way cooler. You can see also clearly the Seine and kind of the cooling effect of the Seine. So really, the type of building, the geometry of the city affect the urban island and the heat in the city. So it's really important to look at all this effect to kind of mitigate it. Next slide, please. And why is it important to look at it? Well, it has economical consequences. So on this graph about that I extract some data from the Swiss Research Institute study, in the UAE, you can have up to 33.7% of global warming GDP loss in 2050. So of course you have different scale, and it's different scenarios that could happen depending on the global warming scenarios, but it's something to keep into mind. And it's even more important in the Middle East and Africa, because the global economic loss are even worse than in the rest of the world. As you could see, the blue histogram is representing the world, and systematically Middle East and Africa in orange always overcome the world number, and also and UAE is even worse. So really, it's of a greater importance for the MENA region. So this problem kind of triggered political action. So I think it was COP28 last year. 71 countries signed the Global Cooling Pledge. The idea was to promote a natural-based solution to cool city down. And the idea is really to reduce cooling emissions, so cooling from air cons or any HVAC system you may have, by 68% by 2050. There was this study of the World Bank Group in 2020 that says that passive cooling solution can reduce the cooling load by 25%. So it's really important. And on top of this, the air conditioning and electric fan already have a cost. They constitute about 20% of the total energy consumed in building, and about 10% of the greenhouse emission today. So really trying to promote passive solution could be an idea. And to talk about passive solution, is important to understand what caused the urban island. So on the right-hand side, you have a schematic produced by the IPCC. So basically, you have 5 main factors that affect the urban island. You have the lack of vegetation and water, which is not a surprise to any of you, certainly. You have less water, less vegetation in trees than in the countryside and in the nature. The city geometry, so really, it depends whether you have really narrow streets where the air can't circulate, and you kind of it's kind of the effect of an oven between the building. If you have a tall building, it also affects the wind. And yeah, so pretty much all the density, the layout, the height, and the size affect the urban island. Our own activity also affect the urban island effect, because if you have an HVAC system, the heat is pushed outside, so you contribute to this warming. And one stuff that is also related to our main activity at One Click LCA is heat retaining property from asphalt and concrete, because these are high embodied carbon materials that we can study the effect in the life cycle assessment with One Click LCA, and they have also high heat retaining properties, which is something that also affect the urban island. So next slide, Leonard. And this is where One Click LCA and ENVI-met together really are a powerhouse for making the city more sustainable, fight climate change, and adapt to climate change. Because One Click LCA really works on the inside, the whole process, all the building itself, from the product stage to the end of life stage, and you can assess all the embodied carbon emission you would have, while the microclimate simulation looks at what happens around the building, such as atmosphere, vegetation, natural surface, radiation, and soil fluxes. And Leonard, in the next few slides, we kind of go through how ENVI-met works and how it represents all these parameters in more details. So,
all right, thanks, Geoffrey. As Geoffrey said, we're now going to dive a little bit deeper into ENVI-met and have a look at what it actually does, how it works. Just some bullet points for the start. ENVI-met is a holistic three-dimensional microclimate simulation model, which enables you to perform 3D simulations of outdoor urban microclimates, and we can enable with this tool very detailed calculations of the different interactions between buildings, vegetation, and the atmosphere. And through that, we get insights into, for example, temperature, humidity, air quality, wind, and also summarizing this thermal comfort of people, so the thermal perception of humans in a certain climate. So we talked about microclimate. So it's a very small-scaled inspection of climate processes, and so in our tool we need a very high spatial resolution. This resolves around 1 to 10 meters usually with ENVI-met simulations, and we have a temporal resolution of 1 to 5 seconds. So when we are, for example, a usual case with ENVI-met is to simulate a whole day in a certain climate with a certain weather. And every second of this day is being simulated, and on the basis of that, we get a very detailed picture of the actual microclimate throughout the whole day. The tool is thought to support sustainable urban design by helping planners to create climate responsive, comfortable, and resilient cities. And we do that by enabling planners to build a digital twin of a planning of a city, of a city quarter, and then light heat and to increase thermal comfort for people. The model has been around for a couple of years now, so the tool is almost 20 or more than 25 years old, built on 25 years of scientific research, has been developed at universities throughout its life, and is already used in over 45 countries with thousands of scientific papers written about it, making it a widely respected tool for sustainable urban design. And also good news, we have a seamless integration with Rhino, SketchUp, and QGIS, so plugins that allow you to basically build your model area for the simulation in these and then just import them into ENVI-met. So that's some bullet points in general about ENVI-met. And the main points of which are being simulated with the tool is on the one hand, and pretty important, we have a full 3D computational fluid dynamics model, which is working in the model. So we can calculate the wind field in urban spaces. Basically, we are calculating air temperature and humidity, which are determined by different sources and sinks of sensible heat and water vapor. Turbulences are being calculated, and also all the relevant radiative fluxes, short-wave and long-wave radiative fluxes are being calculated in the model. And if you want, you can also simulate or calculate the pollutant dispersion, which we will have a look at in a second. This slide is just to explain you what ENVI-met basically takes into account. And being a holistic microclimate model, we try to take into account everything that somehow plays a role in defining a microclimate processes. So we take into account the different radiation fluxes, as I've already mentioned. So the shortwave radiation coming directly from the sun, long-wave radiation coming from the atmosphere. We take into account the different, maybe I'll show you with my mouse if that's possible, the different interactions between buildings and the atmosphere. So the energy interactions, energy exchange between these elements. We take into account the energy interactions between the soil and the atmosphere, but also the humidity exchange from soils. And then what's very special about our tool is that we take into account the interactions also of vegetation and the atmosphere, and through that we can, for example, simulate the effect or the cooling effect of transpiration by a tree and by the whole vegetation that is located in a certain area. So in a whole, we try to take into account everything that defines microclimate. We have different scales that you can do microclimate simulations with ENVI-met. So for example, you can do single building simulations. As you can see here, we have a quite detailed model of a building here, and ENVI-met was used to calculate the thermal comfort in these patios here and around the building. Then we can also have a look at single city districts, which are around 500 by 500 meters big, and we can even go bigger than that and simulate whole parts of cities. Maybe if the city is small enough, we can also simulate the whole city, and something like a 2 by 2 kilometer size of a model area is a common thing to do with or to simulate with ENVI-met. Now, what do we need for an ENVI-met microclimate simulation? It's basically three things. We need a model area that we need to create, either with our ENVI-met internal tools or with one of the plugins. And these contain data about buildings, services, vegetation, and also sources of pollution. Then the second thing that we need to know is, is weather data. You can also create your own weather data with ENVI-met tools, so you're not dependent on finding weather data. But in the optimal case, and it's also available freely from various sources, you can import weather data in the format EPW, TRY, or CSV. So, for example, if you have weather station data, which is widely available, you can use this to perform your microclimate simulation. And then we need a capable Windows machine. You can run your own simulations on your personal laptop, for example. That's perfectly fine to do. So it works on a normal business machine. But what we recommend is that your simulation machine has a powerful CPU, something like an Intel i7 or Ryzen 7, Ryzen 9, Intel i9. Something like that is very useful for ENVI-met simulations. 8 to 16 core processors. A decent amount of RAM is also suggested, so something about above 33 gigabytes is good, and also you should leave some space free on your disk so that you can be sure that everything from the output files is being saved in the end. So now we are just having a quick look on some of the data that you can analyze with ENVI-met. Some of the output data we will have a look at. So, for example, if we're taking about radiation, we can analyze comprehensive data about that with ENVI-met. Here we have, for example, the sun hours of the different surfaces in our model here. So we can see, for example, that this is the same model here, that these sea areas here, they get the most sun hours because they are not shaded, of course. And then if you look at these street canyons here, some of these have below 1.5 hours in a day that are getting direct solar radiation. And then we can do the same for the building facades as well, and see here, for example, that the roofs have the most sun hours over the day. So this is one part of analysis that you can do with ENVI-met. Surface physics, we can simulate dynamic surface temperatures and wall temperatures in ENVI-met. We have quite a detailed approach in modeling soils, so they go up to 4.5 meters deep into the ground. And also our wall model is quite detailed and consists of up to 3 layers of materials. And then we also calculate the energy interaction between the different layers of a wall. So we try to be as detailed as possible with our simulations. This is possible. I have talked about wind flow modeling. As I said, a full CFD model that is incorporated in the model. And based on that, we can also do our wind analysis. We can see where we have a good ventilation, for example, where we have higher wind speeds, and then also we can assess areas that may need a better ventilation that have lower wind speeds. And we can, as you can also see, do all of these analysis either in 2D maps or also in 3D if you want. Green and blue technologies are an important factor in modern urban planning, I would say, and we have different ways to integrate green technology. So vegetation, basically, you can implement vegetated surfaces like grass. You can implement trees into urban areas, but what we also implement is facade and roof greening. So you have a wide range of measures that you can take to increase thermal comfort in urban spaces. Vegetation analysis is an important factor and is there to underline the fact how detailed we try to build our model. So basically, vegetation is not just a dead element that is standing in a space and is casting shade to a surface, but our trees are considered to be living objects. They take up water from the soil. The soil loses water through that. The plant is performing transpiration and is also then reacting, for example, if it can not take up enough water to cool its foliage. We can have a look at transpiration rates of the trees. We can actually see how trees feel under certain conditions, and basically this shows how detailed we try to be in the end with this model. And this is one point why ENVI-met stands out to competitive software. Pollutant dispersion. We can have a look at different pollutants such as ozone, CO2, NOx, and also particulate matter in PM10 and PM2.5. And we can have detailed analysis on how these pollutants disperse through an urban space based on the wind field. And last but not least, and maybe one of the most important factors, is that we can assess the thermal comfort of people. And when we look at thermal comfort of people, we don't only look at the air temperature, which is often used to assess how hot it is in a day. But we take into account way more than this. And this is why ENVI-met enables you to calculate these thermal comfort indices. You may know the UTCI or the PET, which are these thermal comfort indices, and they assess human perception of heat on the basis of air temperature, but also wind speed, the humidity of the air, actually what the person is wearing, so the insulation of the clothing of a person, but also you can take into account, for example, the gender of a person, the metabolism of a person. So it's a way more detailed approach into assessing thermal comfort of a person in a certain scenario. All right, now Geoffrey will take over and we will have a look at some case studies out of the Middle East region.
Yeah, thanks a lot. So just to give you an idea of how ENVI-met works actually in action, we will look at first a case study about Dubai. So if Leonard, you can switch slides. So the idea is, well, we need to reduce heat in Dubai because, I mean, I've been only once, but it's really warm there. So that's something you need to look at. And two ways to do this is actually, it's an interesting case because you have two type of city layout. So you have the layout around the Burj Khalifa where it's kind of open and loose fabric with only a single, the greatest tower in the world. And then you have the Deira, which is more narrow streets where the air struggle to go in and you have low ventilation. So that's really two different cases, and we can show you in the next slide how some solution applied to both layouts could reduce PET, which is a measure of heat stress. It's a fat-like temperature, so it's a corrected temperature according to the humidity, sun, physiology, and other parameters. It's really to see how people would feel in this area. And in DERA, if you kind of try to widen the streets, you would reduce the PET by 10 to 15 degrees, which is a lot. If you had some local water feature, the evapotranspiration process also contribute to reduce the PET by a further 10 degrees. So in total, if you combine putting local water features and widening the streets in the DERA, you could get a PET drop by 20 to 25 degrees. And this is the kind of simulation ENVI-met allow you to do, because it's hard to push building in real life, but you can do it in the software and then look at the effect. And the same, adding a water feature, it's easier to look at it in the virtual world rather than just putting it in real life. But that's a solution you could apply. And for the Arab, the Burj Khalifa kind of native vegetation can reduce PET by 5 to 10 degrees. We noticed that actually a solid shading can really reduce the temperature by 10 to 15 degrees. So it really shows that protecting people from solar radiation is the biggest factor in the Burj Khalifa. So you can see also the impact of the different solution and the advantage and the drawbacks of different solutions. So that's really something you can work on your design. So for the MENA region, you can try on a different layout. Now we can look at another case study about Abu Dhabi. So it's really the idea is to get walkable outdoor spaces in Abu Dhabi. Next slide. So this case study is interesting because you can look at also the whole workflow with ENVI-met using our Rhino plugin. So there was first we look at Rhino to create our geometry. We specified the 3D area with Grasshopper, implement some use the weather data from Ladybug, and then run the simulation with ENVI-met, and you got the output data. So you see all ENVI-met can be integrated in an existing workflow. Next slide, please. So the reference scenario, so the case study is in an area composed of mixed and retail building. It was made around the 21st of May, which is considered as an average warm day. So it's really to see a representative day in the region. Next slide, please. So the idea of the first scenario was to add some detailed facade, change the pavement, add some palm trees, covering half of the site with grass, some shading trees inside the site, and some asphalt road finishing. And if you could look at the comparison of the different scenarios, so the little map show you the output in ENVI-met, you could see a drop of 2 to 4 Kelvin in air temperature, an increase in relative humidity. Because of the shading, the mean radiant temperature, which is also looking at the radiation of the different building around, it dropped by 20 Kelvin. And also because you have the air purifying quality of vegetation, you have a drop in CO2 concentration in the area. Let's see the scenario 2. In the scenario 2, so green facade been added, and also some green roofs been added. Grass is covering the whole site, and the asphalt road has red coating. So you can see you have a drop in air temperature still, but a bit less also increase in relative humidity. The mean radiant temperature also drops. The CO2 also drops. So you can see the different solution, what it could benefit, and which one is the best regarding to constraint in your project. Next slide, please. And on the third scenario, we try to get a basalt brick road, concrete pavement, but this time with a light color. Added some water body on the side, and significant use of shading trees inside the site. So you could see you have a drop of 2 to 4 Kelvin, an increase in relative humidity, a drop in mean radiant temperature, but a bit less than the other solution, and also purifying the air by 21 milligram by cubic meter. And now, Leonard, we kind of show you, actually, because on Monday, we released ENVI-met version 5.7, and you will kind of describe you the new user experience update we have.
Exactly. So ENVI-met is developing. It's a developing model, and we try to make it better basically every day. And we just had a big release coming up, the ENVI-met version 5.7, which has included some major user experience updates. So we have upgraded our graphical user interface for better usability. We have tried to make it easier to use the software basically. And we also now have a new file and project management system, which enables you to more easily manage your data, especially when you have bigger projects. Then things might get messy, and this prevents this from happening. We also have a better integration now with our plugins, so QJS, Rhino, and SketchUp. And we also, for new users, for people that have not done a microclimate simulation before, we have added a little sample project with also some training content attached to that, basically to enable you to learn more about the model. For microclimate simulation geeks, we have also improved some simulation stability. We have integrated fail safes, especially for new users. This is important, and also the thermal comfort indices are now automatically written into the standard output, and this basically makes your life easier. That's about the new updates from our recent release. And now we have one last question for you, which would be if you would consider adding microclimate simulation to your workflow or services. So yeah, we would be happy to get an answer for that for a short time. And I think now I give my word to Natasha.
Thank you. Thank you so much, Lanat and Geoffrey. That was very interesting. So now we will go to the live Q&A. All right. You can also continue answering to the poll question as well. I guess it's already live. So the first question we have is from Manohar. Is it a continuous assessment tool for all seasons?
No. ENVI-met is considered to be a tool used for especially heat stress events. So for summer season, it is best suited. You could also use it for spring events and also autumn events. I wouldn't recommend it to use for winter simulations. There's not a lot of point in that. So it's mainly used. It's really good at heat, basically.
Okay. So definitely for like tropical climate and Middle East climate. So
Definitely,
yeah. So does it include the integration of sensors? I think climatic sensors. I'm not fully sure if this question is.
If you mean like climate sensors that are tracking weather data over the day, you can implement this data into an ENVI-met simulation and use this data in the end to perform your simulation. This is possible. I hope this is the answer to the question.
Yeah. So I believe the data from the sensors can be included into the software.
Yeah, exactly. Yeah, it's
the data.
Yeah, the data can be in CSV file format, which is the usual format for these weather stations, and then you can implement this data. Yeah.
Excellent. The next question is, this tool can also update what is the current outdoor shading, and is it required to meet thermal comfort or UTI? What is the current?
I may not have understood the question correctly.
No, I think what they're trying to ask is, like if you have a shading device, how does it reduce the current temperature? Can it like show comparative data? I think that's what they're trying to ask.
Yes.
Yeah, exactly. Yeah. I don't know, Geoffrey, if you want to answer.
Yes, well, basically, especially in our data visualization tool, you can run your reference scenario, and then you can do a second simulation with your shading, and the software provides you just a difference, so you can see between your scenario your difference. Actually, this is how the case study work. In general, you run the reference scenario, and then you run your modified design, whether you have add shading or actually any other feature, and you look at the difference in your parameters. So yes, definitely.
So you can
All right.
basically directly quantify the impact of your heat mitigation measures.
Yeah, and this meets the thermal comfort. Like we can see how far we are off also.
Yeah.
Okay,
Exactly.
okay.
Yeah.
Yeah, I think Wasim, that answers your question. Rauba has a question. I'm interested to know how wider exposed streets can lower PET while narrow streets will provide shading.
So urban climate is a quite complex thing to think about, and that's why we also offer this tool, because you need to analyze it with this tool. Basically, you can't say directly what measure is going to have what impact, and it's also various impacts. So if you, for example, have a narrow street, you may have more shading there, and you may have better thermal comfort over the day. But an issue there could be that you have reduced ventilation, or that and by this reduced ventilation, you have a less cooling there, and this then could result in higher nighttime temperatures, for example, than if you have a wider street which can cool better over the day, or in the evening, or in the night. And this, for example, can be a factor that increases the urban heat island effect. So the city heating up more. So it's not that easy to say exactly what measure is going to have what impact. We always need this holistic context, and this is why also ENVI-met is a holistic model. We take into account everything that plays a role in defining microclimate, and then on the basis of that, after you have performed your simulation, you can see, okay, what is going to happen if I going to implement this measure and this measure and this measure. So
Yeah,
basically, to give an answer to that, we would have to perform a microclimate simulation.
agreed. I think what you are trying to say is that it's not like a design philosophy that, if you have narrow streets, that it is going to reduce the temperature. It is not like that. It's purely
Yeah.
geographic and even time based also.
Maybe to give another example to that,
Yeah.
there have been a let's say misconception of, for example, increasing the albedo of surfaces in cities. This has a good impact on the heat island effect, because we are reflecting more radiation into the atmosphere again, and by that our cities are cooler. But this then also has a negative effect on the humans which are standing on the street, which has a higher albedo, as we are not only receiving direct solar radiation from the top, but now we are also receiving this radiation from the surfaces reflecting this solar radiation. So the thermal comfort may be worse at day if we increase albedo in some cases. So we always need to have this context in mind.
Okay, very interesting. All right, I did not know this. Thank you. So the next question is Norhan. Can you provide guidance to learn connection of ENVI-met with Rhino and how to use Rhino models to run ENVI-met? Uh,
Yeah.
yeah.
So I don't know, Geoffrey, you want to answer it, or I'm going to answer it?
I will just say one thing.
We
We do have a course on our academy, so you can always go to that. I can put that, but Geoffrey is going to talk more about it.
Yeah, well, I was just saying that to say how to learn the connection with Rhino is we have a plugin. So basically, you plug in, you can apply your model to you can convert your Rhino model to ENVI-met. So this is how you get the connection. There is a documented actually a software plugin guide which can help you. There is even we provide also example of a workflow which get you from your Rhino design to an ENVI-met simulation. So this is how you can learn it. Of course, once you get you work with ENVI-met, we also provide support. So you can also have help. There is the academy course. Yeah, I think that's pretty much all the support we can provide you into learning Rhino. But yeah, the example workflow works really well to learn it. I think that's especially if you have experience with Rhinos, that's the easiest way to get into it.
All right. Thank you, Geoffrey. And the next question is how the software takes into consideration the impact of pacing materials / colors. That is pavers,
Yeah, so we assign we have a database of different materials that you can use for a surface, and these materials have physical properties to them. So they have a value for reflection, they have a value for absorption and transmission, and based on these values, the calculations are being done. So if you have a lighter color, you have more reflection of a surface, and on the basis of that, yeah, the calculations will proceed. So all of the materials that you put in have physical parameters attached to them, and based on that, we do the calculations.
So you can add these materials from the database that is already pre-fed into ENVI-met.
Exactly. And you can also, if you have a special project, implement your own materials. So you can create your own material with a certain reflection value to it, and then run your simulations with that.
Oh, excellent. Okay. In terms of design scenarios, is there an option for optimization in the ENVI-met software? I think you've already answered this.
If I get it correctly, like you are able to design different scenarios, different designs in different scenarios, and then compare the outcome of these simulations. That is possible, yeah.
Can it also be used for wind pedestrian comfort analysis, combining wind CFD simulation with 12-hour plus wind direction with wind data to output frequencies for wind speed? So, can you model CFD basically?
It has implemented a full CFD model, and you would be able to do these calculations with that, yeah.
Yeah, and you can also combine it with the EPW and files and everything.
Exactly, yeah.
Can you tell us more about air quality simulation works? Do we get to know what parameters we can measure and where to place the sensors? Oh, very interesting question.
Geoffrey, you want? I'm sorry.
Well, I was just thinking it's a dispersion model, so you get a dispersion of all the different pollutants are going. After we have a different pollutant, so you will see on your layout where are the most important blockage area for your pollutants, or where are the most interesting area to place your sensor. After
maybe
yeah, you can go.
Maybe adding to that as well, if you so sources of pollution would be in ENVI-met would be streets, or can also be a single point source, or it can be a whole complex like a construction site, for example, can be a source of pollution. And you would, for example, in the case of a street, you would define a daily traffic value. So, for example, you say 8,000 cars are crossing this street in a day and then you can also define the composition of the traffic. So, have we got heavy vehicles driving there? Have we got maybe the most amount of vehicles is motorcycles or private cars, and you can define the emission profile on the base of this, and then this is being considered in the simulation, and on the base of this, the pollutant distribution is being calculated.
Yeah. So the next question is, great presentation, Geoffrey. Please, can I adapt the simulation for sub-Saharan African region?
Yes, I recognize the name. It's Dr. Kwabena Fosu-Amankwa, who I worked in previous venture in Ghana. So I assume he's especially interested in Ghana. So yes, you can work on it for Ghana. Of course, you just need a good map of Kumasi, especially, and you can run the model there. So yeah, especially for your pollutants, he's especially interested in air quality. So yes, you can run it in a sub-Saharan region.
Okay, great. Can a complex topography be implemented in the model?
So you can implement topography in the model, yes. We recommend to not do it if you really don't need to do it. But if you have like a hill in your city, then you obviously need to implement this topography. So yeah, it's possible, yeah. And also
through the integration, yeah. Through the integration, it should be easy, right? Like
yeah. For example, if you're using if you're using one of the plugins, basically all of these are possible to integrate these topography structures, and then you can import them into ENVI-met directly. Yeah.
All right, all right. There is a follow-up question from the optimization question. That is, they want to know if it can optimize automatically. Like if you have like one design and it says that these are the factors, will the software show like like a quick or like an automatic optimization, like where you can improve certain areas?
No, you would have to do this analysis yourself, and then on the basis of that, perform your own changes and think what would be the best mitigation measure, basically. So there's
Yes.
no automatic answer to that.
I think it is also because it's very subjective, because every location is different and how you react, and the temperature, I mean, the thermal comfort is very different in different areas.
Yeah.
And also it depends on what you're allowed to do, because it depends
Exactly.
on your constraints. So there's quite a lot of constraint and modification. So you have to pick what modification you're allowed to do. So there's a lot of
Agreed. The next is they want a course on linking Rhino models to ENVI-met. So I don't know if we are going to develop a course, but if you are working on a Rhino and you want to use it with ENVI-met, then we can definitely support you in enabling this for you. Right? I think that's how we can answer that.
So we have a course in production about the Rhino plugin. It will come out in the next weeks, actually.
Okay, nice.
And if you have the license, or if you buy the license, you also have the possibility to get a support from us in the form of a support pack that we offer, support hours. So we can also actually we can give you a personal training on working with ENVI-met. Also, this includes the plugins, of course. So
yeah. I think that's about it from the questions. Let me check if there is any other questions. Can you give rough estimates of the calculation time?
Yeah. So a 500 by 500 meter model area, I think at a resolution of 2 to 3 meters would, on a decent simulation machine, as I stated in my slide, so good maybe Intel i7 processor, something like this with 8 to 16 cores, would take up to 1 or 1.5 day to simulate, something like this. So take some time to do these simulations, but they are very detailed. As I said, it's every second that is being calculated, and every second different meteorological calculations are being done. So it's quite a complex thing to be performed by a PC.
Yeah, I'm also putting the link for the configuration that is required for like your laptop or a computer, so you can even explore that. But I think that's about it from all the questions. And if there are no more questions, I guess we can move ahead. So yeah. So we have some resources that you can explore. One is if you go to One Click LCA, and if you go to the academy, like I said, we already have a course on ENVI-met. It's quite detailed, so you can learn how the simulation works, how it changes, how you can effectively change your design. Because as far as I know, like most architects and engineers only look at physical building simulation, that is internal building simulation, but we are never looking at an urban scale or like as a microclimate simulation. It is not an energy calculation software. It's a different approach to energy modeling, because it's about how to effectively create an environment which is cooling for anyone who walks or lives there, basically. So I think it's a very interesting course. You can definitely explore. All of our courses on One Click LC Academy is free. So I would suggest that you explore these courses for yourself. There are lots of interesting and a lot of information based videos on there. Uh, you can scan the QR code. And of course, there's also a YouTube channel which talks about all the different ways that you can use ENVI-met to create microclimate simulation. This is a fairly new topic. So I would suggest that you explore it yourself, learn for yourself first, and then of course we can definitely discuss about how you can purchase the software and how it would help your designs. Um, and next, I think, yeah, that's about it from our side. If there are any questions, we still have 4 minutes. So if anyone has any questions to ask, while we have Lanat and Geoffrey, who are the experts in this field, you can please ask us. Otherwise, we can wrap it up. All right. I think there are no more questions.
Ruba Nassar has written that it was really beneficial. Thanks for that. Happy that this was
effective.
Thanks for your time. It was.
All right. Thank you, everyone, for joining the session. And if you have any questions, of course, you can always send us a message or an email at sales@oneclicklca.com. One of us will definitely reply to you with an answer. Please feel free to use all the resources that we have for free to upgrade and upskill yourself. All right. Thank you. Have a nice rest of the week.
Thank you.
Thank you. Bye.
Bye.
Bye-bye.